This is Algebra 2 Lesson 10-9, Multiply and Divide Rational Expressions. The easy version. Today's date is Friday, April 24th, 4/24, 2020. Our objective today is to multiply and divide rational expressions with monomials, and that means the numerator is a monomial and the denominator is a monomial maximum. There's no binomials or trinomials yet, but that will be happening. So, rules for multiplying and dividing. Whenever you multiply, and I guess dividing rationals, I should be saying, whenever you multiply fractions, you're just going to multiply the numerator by numerator, or more simply, the top by top, and bottom by bottom, and bottom by bottom. Visually, what that looks like is if I had a picture, if I have like these two fractions multiplied, I'm just doing shapes. What shape do I have here? Sure, an X. If you were to multiply these, you just squish them together. You say the top is square times triangle, all divided by circle times the X. You just multiply straight through. Whenever you divide, though, you guys know this rule very well by now. You keep it, change it, flip it. Keep, I should have a space there. Keep it, change it, flip it. And then it goes back up to the rules that were up here. So let's see some more review, and then we'll do our first example. When I am using rules of exponents, let's say a and c are some coefficients, x is our variable, and b and d are some numbers. The coefficients you multiply, so the coefficients are going to be a times c, and then it's going to be x to the power of, I'm going to add the exponents b plus d. B plus d. And then when I'm dividing and I have the same base, I'm going to subtract the exponent. So this is going to be x to the power of b minus d instead of b plus d. And again, you'll have to simplify the coefficients as well. I just didn't put them in here because there's no way to do a general form of simplifying that. Okay, so let's try 3 examples and then we'll be done. So example number 1. Let's answer this question later. Let's go ahead and just do the math. So if I multiply these straight through, you can essentially just make this fraction really big and say these are all being multiplied by each other. So it's one giant fraction. Let's go ahead and cross cancel as much as possible. So notice that 21 and 7, 21 is 7 times 3. So if I cross cancel these, I'm left with just a 3 in the top and 1 in the bottom. And what about this x to the power of 3 and x? This is really x to the power of 1. So I can say this is x to the power of 1. So I don't know if I'm skipping too many steps here, but I'm going to do the power of 3 minus the power of 1. So it's going to be to the power of 2. So our final answer here is going to be equal to 6 times 3. The 6, this 3, right? And then it's going to be x to the power of 3 minus 1. And 6 times 3 is 18. 3 minus 1 is 2, so 18x squared is our final answer. Okay, so let's read this. For the result to be equivalent to the original expression, can it be defined at x equals 0? And the general way that you want to be thinking about this question is a variable ever in the denominator? So do you ever have something, I don't care what's in the top, but do you ever have like an x in the bottom? If you do, anywhere, then you can never have this defined x equals 0 because you would be dividing by 0. If x equals 0, this 0 is being plugged in to that x, and that's the definition of being undefined. It's when the denominator is equal to 0. So let's look at our equation and our answer. So in our answer, there's no denominator, so we're safe there. But notice over here in the original problem, I had an x in the denominator before I simplified, so the answer here is no. No. It would have made this rational expression undefined. Example number 2. Again, another multiplication problem, so multiply straight through. Again, kind of treat this as one giant fraction and start cross-canceling. So 18 and 4 both are divisible by 2, so 4 divided by 2 is 2, 18 divided by 2 is 9. What else do we have? 5 and 15, those can cross cancel. Maybe I should do that in a different color though. So 15 and 5 both are divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And then these exponents, I'm going to add them because they're both on the top. So our intermediate answer, we have 9 times 3 in the top, so 9 times 3 in the top. And then I have a to the power of 3 plus 2, 3 plus 2. And then in the denominator, I have 1 times 2, or just 2. Okay, and then simplifying this a little bit, 9 times 3 is 27. This is a to the power of 5. All of this divided by 2. Final answer, box it. Again, the same question. And now, do you ever see an x or any variable? In this case, I should have said a is equal to 0. That's a typo because there's only an a. Is this defined at a is equal to 0? And the answer here is actually yes, because there's no variable in that denominator, no variable in that denominator, and no variable in that denominator. All the denominators are clear variables, therefore you can plug in 0 for the variable. Okay, let's try example number 3, and then we're done. So I finally have my first division, so immediately I'm going to keep it, change it, flip it. That's my first step. So this is 12c to the power of 5 over 5. I just recopied down my first rational expression, so I kept it. I'm going to change the division into a multiplication. Oop, that was a bad error, but you guys can see. And then I'm going to flip it. I'm going to take the reciprocal of this, and it's going to be 15 on the top instead of on the bottom, and a 4c to the power of 5 on the bottom instead of the top. All right, so let's go ahead and start cross-canceling. What do we have? So immediately I see a 12 and a 4, both divisible by 4. 12 divided by 4 is 3. 4 divided by 4 is 1. What about this 15 and 5? So 15 and 5 both are divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And notice I have a 5 and a 5. One is on the top, one is on the bottom, so I'm going to be subtracting them. So what do I have here? I have 3 times 3, and this is going to be c to the power of 5 minus 5. What about the bottom? Bottom is just 1 times 1, so it's just 1. I can ignore it. So my final answer here is, maybe not my final answer, it's 3c to the power of 0, and anything to the power of 0 is 1, so you can think of this whole c to the power of 0 is just 1. 3 times 1 is 3. 3 is our final answer. Oh my gosh, I did not even catch that, I'm sorry. 3 times 3 is not 3. 3 times 3 is 9. So I have 9c to the power of 0, and repeat that, c to the power of 0 is 1, and therefore 9 times 1 is 9. Final answer is 9. Again, we have the question, can you plug in x is equal to 0? And yikes, it's another error, making them left and right. It should be c is equal to 0, because that's our variable in this case, right? Okay, check every single spot. Do you ever see a c in the denominator? No, no, no. Oh, check that out. I do now, so the answer is no. If you ever see a variable in the denominator, the answer is always no. Cool. That concludes notes 10-9. I'll see you guys on Monday. Have a nice weekend.